Question 24. Given f of x, remember f of x is just another way to say y, 2x squared minus 3. Which statement is true about the average rate of change of the function? Big idea here. Rate of change to me has always been, how much does the y change, like y2 minus y1? Some teachers would say change in y over the change in x, right? So then you would have to subtract those values. When I think about something, the rate of change, that's what I'm thinking about. Let's look at this example. If a car travels 120 miles in 2 hours, the average rate of change is what? Well, you know that they've gone that many miles. We're going to divide by how long they've been in the car. And 120 divided by 2 is going to be they're averaging 60 miles per hour. Now, visually, and we don't have a visual here, I always go back to something like this. So if I'm given a line and I'm thinking about my equation that's at the top right here, I'm saying to myself, okay, change in y, this is my y line. How much did it go up? And then how much did it go over? And that's the big idea that I think we're looking at, except the problem is we have no visual and we really got to earn this. Okay. The first thing I'm going to look at is I'm going to say, okay, can we plug in? We're always trying to plug in. We see numbers 0, 1, 2, 3, 4. Those are all of our numbers. So what I would probably do is I would probably make a little chart and we're going to get some numbers and we're going to see what's going on because something happens between 0 to 2, for example. But I'm going to write them all down. 0, 1, 2, 3, 4. And I know to stop there because there's no numbers going here. Ultimately, I know when I see an x squared, this is like a U-shaped graph, and so I don't have all the details. At the very end, I'll put up an example of what it looks like on Desmos, but I'm not going to focus on that right now. We're just going to kind of earn these points, and then we'll talk about, they tell us the answer, so only one of those has to be right, and so we'll kind of calculate it using our thinking. Okay, so let's plug in the number 0. Happens to be the easiest one. 0 times 0, that's 0. 0 times 2 is still 0, so 0 take away 3, that number would be at -3. If we put a 1 in, again, we're replacing the x because the x is the number 1. So 1 squared, 1 times 1 is 1. I then have to times it by 2, so 2 times 1 is 2. And then I get 2 minus 3, that's going to be -1. Similarly, we're going to do it with 2, 3, and 4. 2. Okay, so 2 times 2, that's 4. 4 times 2, that's the number 8. 8 minus 3 is 5. Now we're going to get even bigger. 3. 3 squared. So x squared, we're kind of seeing this. This is a number times itself. 3 times 3 is 9. Then you have to times it by the 2. So 9 times 2 is 18. 18 take away 3. We're all the way up to 15. Now we have 4 squared. 4 times 4 is 16. 16 times the 2 in front is going to get me all the way up to 32. And then I got to take away 3, and that would be the number 29. Okay, why am I doing this? Okay, so if we're thinking about the average rate of change, they're telling me right here that between 0 and 2, the average rate is 1. Okay, so again, I have to think about the top part, and I'm going to be dividing by a bottom part. We know that from 0 to 2, we went from 5 to -3. So I'm going to come over here. 5 minus -3, and in that distance was the same time of 2 minus 0. 2 minus 0. Well, the bottom's easy, so let's take care of the bottom. We know that's a 2. When you minus a negative, remember that's going to turn into a plus. So that ends up being 5 plus 3, which is 8. But 8 divided by 2, is it that number? No. So that's why we don't like that question. If we do the second question, we're coming between 0 to 1. So that means I'm coming from -1 and I'm minusing -3. And on the bottom, that's from 1 minus 0. So the bottom is a 1. -1 minus -3. Again, that's going to turn into a plus. So then it ends up being -1 plus 3, which is going to get you the number 2. But 2 divided by 1, nope, it's not that number either. So you have to work your way down the line. Um, in some ways, the bottom was probably a little easier because what we were changing was from 3 to 4, for example, from 3 to 4. 29 minus 15. 29 minus 15 is going to be 14. And the distance here was I'm dividing by 4 minus 3 by 1. Nope, still not that number. Okay, from 2 to 3. Okay, how about 15 take away 5? And I'm dividing by 3 take away 2. 15 take away 5 is 10. 3 take away 2 is 1. 10 divided by 1. I think that's the only one left. Let's see if we can get this one right. Okay, so I'm going to move it up. We're going to write it right down here. So from 1 to 2, they think the answer is 6. Okay, from 1 to 2. What is 5 minus -1 divided by what is 2 take away 1? Well, the minus and negative, it was very present here. This is going to be the number 6. And on the bottom, we have the number 1. And 6 divided by 1 is 6. So C is the correct answer. I do not think this is an easy question, but this is a very big idea. Understanding how much is something changing versus the amount of time that has changed. So pay attention. I think these questions, as example, had a spacing of 1. This one was a spacing of 2, so that one was probably a little harder compared to these other ones. Good luck. Stay positive. This is a little longer video, but it's also question 24, so you're near the end. Keep up the hard work.